Good morning and welcome. This is 11.7 exponential functions. So we have worked with linear functions, which is y equals mx plus b. We've worked with quadratic, where you have an x squared. We've worked with cubic, where you have x cubed. We've worked with radical functions, where you have the square root of something. Now we're going to work with exponential. What that means is you have y equals any number, I'll just say 3 to the power of x. So your x is now your exponent. That's why it's the exponential functions. So let's say we use our example here on 11.7. They're talking about evaluating an exponential function. So that's the first step. When I have something like this, the f of x, or the function of x, equals 2 times 3 to the power of x. It uses that as an example, okay? And then in the model here, it says that this represents the model of an insect population after x days. So the x represents the number of days. What will the population be on the 5th day? All I'm doing when I evaluate, I'm finding that value. So this function of x is the same thing as saying y, or your end result, is going to equal 2 times the power of 3. After 5 days, if x represents the number of days, I just plug in a 5 there. Now I'm going to use my calculator. Remember, with exponents, I'm going to do this 3 to the 5th power first, and that 3 to the 5th power is 243, and then I bring this 2 down, okay? And then I multiply that by 2 again, and I'm going to get 486. Let's go ahead and go back at look at the question though. It says, what will the population be? And we're talking about insects here. So in this case, we do want to label it. Our population would be 486 insects. Now we want to make sure that it is a whole number. In this case, the way that you work it out, no matter what, you'd get a whole number. But if it's talking about animals or live things, we can't have a partial part, so we have to have a whole number there. Let's go ahead and do the example at the bottom of the page as well. So it says this function, f of x, equals 8 times 0.75 to the power of x. Okay, so this is an exponential function, and that models the width of a photograph in inches after it has been reduced by 25%. Okay, x times. So x is the number of times it has been reduced. I don't need to know any of the other information. The 25%, that's because if I'm going with subtracting, I'm deleting 25% each time, so I'm actually using 75%. So that's where that comes from. But I don't need to know that. They gave me a function rule here. What is the width of the photograph after it has been reduced 3 times? So that means my x is going to equal 3. So I'm going to go ahead and rewrite the same equation with a 3 here. Again, I do the exponent first. So 0.75 to the 3rd power is a 0.42. I'm going to go ahead and simplify it there, round it there, multiply that times 8, and I should get 3.375. Let's go ahead and go back, and this is the width of the photograph in inches. So I'd say 3.375 inches. Make sure that we label it properly. Okay, now I've already set this up. This is the example at the top of page 739. Okay, and this is using an exponential function where we have points. The model of an exponential function, this is the way it works. When I look at the left-hand side, or the x values, I always add, and in this case I add 1. And so it's a consistent, I add 1 each time. So I should add on the x side. On the y side, I should multiply. And I know that to get from 6 to 18, I multiply 3. And 18 times 3, using that same constant, is 54. And then if I multiply by 3 again, it's 162. So an exponential function means I add on this side and I multiply on this side, okay? So that should be the case. Now we're going to use 2 examples. Under example 2, this is 2a, and I wrote the points that they gave us. I already put it in a chart, so I want to double check what happens there and if it creates an exponential rule. So in this case, I do add 1, I add 1, I add 1. Here, I subtracted 1, or I multiplied by 0, okay? This one, I added 2. I can't really multiply by anything. Here I added 2 or multiplied by 2. So there's not a rule here, so this is not an exponential function. It does not represent an exponential function. Let's go ahead and try this one. I add 1. Okay, I add 1. I add 1. So to get from -2 to -1, I added, I add. Okay, now this one, I would divide by 2, or I could subtract 2, or I would divide by 2, or, remember we want to work with multiplication, or I multiply by 1/2. So let's see if that works. I'd either add 2, okay, so that's out. Do I multiply by 1/2 to get there? I sure do. And 1 times 1/2 is going to give me 1/2. So this right here, I have a constant that I multiply on the y side, and I add on the x side. Ooh, okay, there we go. So that's a great example. Now our next step with exponential functions is we are going to graph. So I'm going to go ahead and put up graph paper here. And hopefully we can see this at home. Let's go ahead and do one of our examples here, and I will write as dark as I can. So y equals, we'll go ahead and do the first one here, which is 2 to the power of x, okay? And I want to create a chart of values. I'm going to start, if I do a -1, remember anytime I have a power of a negative, it flip-flops it, so that would become 1/2, 1 over 2, so this is 1/2. What is going on? Okay, 1/2. And then if I put 0, anything to the 0 power is 1. If I put 1, that's 2 to the 1 power, which is 2. If I put 2 here, that's 2 squared, which is 4. Okay, and if I do 3, that's 2 to the 3rd power, which is 8. So we can kind of get the idea now. Now I do want to get my lines. And now we can graph it, okay? Remember, a linear function is always going to create a line. A quadratic would create a U or a parabola. A cubic creates the weird little squiggly. A radical creates the half a parabola that goes sideways. So let's see what this would do. I go -1, that's going to give me 1/2. That's pretty small there. Okay, 0 is 1. 1 is 2. 2 is 4. 3 is 8. Now, this is going to go up like that, but it's also going to come out here and it's never going to touch that line. So it's going to go very close to it, but it will never touch it. Okay, that is what an exponential function looks like. Now, if I continued going to the right, it would continue getting steeper and steeper and steeper because it'd be a higher exponent. Let's try another one. Let's do, we'll go ahead and give the example that they have here. So 3 times 4 to the x power. So now we're not only doing something to an exponent, but we're multiplying it in front also. So let's go ahead and let's say I have a -1 again. Now I'm saying 3 times 4 to the -1 power, which gives me 3 times 1/4. So here I have 3/4. Okay, I'm going to go ahead and erase that word just so that I have room here. If I had a 0, I'm going to say 3 times 4 to the 0 power. Well, 4 to the 0 power is 1, so 3 times 1 is 3. If I put a 1 there, I'm saying 3 times 4 to the 1 power, which gives me 12. Do you see how large it's going to be now? I'm going to go ahead and stop at 3 points just because I don't want my graph to be ginormous. So we'll go ahead and do this. Create our x and our y axis. Okay. And then I'm going to go ahead and go -1 is going to give me 3/4. It's still not even at that 1. Oops. It's still not even at that 1. Okay. And then I have 0. It's going to go up to 3. And 1 gives me all the way to 12. 2, 4, 6, 8, 10. All the way up here. Rewind. Okay, so again, it's very, very steep. Anytime you have a constant in front of your number with the exponent, it's going to be a very steep graph. Okay, and again, it's gonna come here, and I still do want you to go beyond whatever that left one is, that far left point that you did, so that you can see that it will still go this way. Do not, don't make it curve, oops. Don't make your line curve up like that. It doesn't go up. It goes along this x-axis, okay? So make sure that we make that clear. Oh my goodness. Make sure that we make that clear so that we can see that the exponential function, okay? Let me know if you have any questions. That's gonna be the hardest part, is the graphing. There are gonna be quite a few of those. And then there are gonna be some where you just plug in the value of x, okay? Good luck, have fun, I'll talk to you soon.